Hello, everyone. My name is Cohen Kadosh, and I'm a professor at the Department of Experimental Psychology at the University of Oxford. And I'm going to tell you today about cognitive enhancement. So, what is cognitive enhancement? It is a question that usually I'm asking while you are the student just in front of me, and I can ask you such questions and we can discuss that in much greater detail. Um, But one definition of cognitive enhancement is the ability of us to improve different mental processes, such as, for example, attention, memory, information processing, and so forth. And the ability to improve these mental processes is due to environmental changes. So we need there will be some changes outside of us in order to cause to such changes in our mental processes. And it will have impact also on our physiological system. And if I give this terminology, then the question, of course, I hope that you all ask yourself is whether you are already using cognitive enhancement. So try to think about um, your everyday life, whatever you are using. If you are using something that, based on this definition, you could consider as cognitive enhancer. One possibility that you might already use is, for example, coffee. Okay, so different types of nutrition um, have been suggested to improve our cognition. So I could hear a lot of people say, "Oh, well, without coffee, I'm not able to think properly." Okay, but this is an example, right? We have an environmental change. We have a cup of coffee, we drink it, it's affecting our physiological systems. There are different ways that it's actually affecting our physiological system, and it allows us, hopefully, to perform better. So maybe to be more attentive, to process information faster. And usually I give one term course about cognitive enhancement. And over there, what did we do? We discuss different ways to enhance cognition. So we were reviewing different pieces from the literature, such as, for example, cognitive manipulation or training, whether it's cognitive training or physical exercise, how it's affecting our cognition, mindfulness, drugs and nutrition, or neurotechnology. And here I would like actually to give you a small taste of the different, not all of those, but some of the ways to enhance cognition. So when we talk about enhancing cognition, I think it's something that it's on the mind of many people. So many people would like to improve their cognitive abilities. And a very good way to see the reflection or the urge of that is in movies. I think movies characterize really nicely dilemmas and things that are on our mind in different ways. Hopefully not horror movies, but this is an example for a movie that was um, that focused on the ability to improve cognition. In this case, the hero, for example, found a pill that if he takes that, it improves his brain power, according to this movie. Of course, it's not a scientific movie, but it just showed how it could improve his cognition, but also what were the consequences of that. And this movie, if you didn't see that, I really recommend you to do that. Reflects a lot of the ethical issues also that are associated with cognitive enhancement. So, is it really you or is it really the drug? Are we becoming dependent on these environmental changes in order to improve our cognitive abilities, or we can actually perform well even without them? But I think it is important to say that our motivation or the ongoing thinking on how we can improve our cognition is not something that is restricted to our present life. So it's not a reflection of how of the society that we live in or the values. It's not something that is, for example, limited to capitalism society. It's something that we can actually track the roots of that thousands of years ago. If you looking on stories, you can find out about stories that discuss about cognitive enhancement. We maybe did not define them as cognitive enhancement, but they are discussing issues that relate to cognitive enhancement. You can post the video for a second and uh, try to think if you can, if a story, all stories can come into your mind that may be discussing about cognitive enhancement. Now, I hope that you found some interesting stories that reflects your culture and so forth. One of the examples that I would like to bring is actually from the Bible. So this is the story of Adam and Eve. And I assume that most of you are familiar with that, in which Adam and Eve were in the Garden of Eden, according to the story in Genesis, and they were asked that they were said by God that they can eat all the fruits in the garden, but there are two types of trees they should not touch. One of them was the fruit of knowledge. And what happened is that eventually they ate this fruit of knowledge. Their eyes were open. So you can just think about the cognitive enhancement here. But you could also see the consequences of that, right? So there was a punishment that were associated with that. You can see in this side of the picture how were they expelled from the Garden of Eden, and the consequences of that, of course, based on the Bible, is that we all need to work really hard nowadays instead of really just enjoying being in the Garden of Eden. So I think it's a very interesting story that gives some of the sides of cognitive enhancement that some people take, which means do not try that. Do not try to get more from what you have. Be happy with what you have. If you're going to try to enhance your cognitive abilities, you might pay a price for that. And remember that because at the end of the lecture, I'm going actually to discuss some of the implications of that nowadays for cognitive enhancement. It is whether we need to pay any price for enhancing our cognitive. So the first example that I want to give you of cognitive enhancement is coming from cognitive manipulation. In this case, we're using some tricks. Is nothing expensive or that it is really difficult to get. It's simple tricks that we can use in order to improve our cognitive abilities. So things like, for example, confidence, or in the way that I'm going to discuss here, to improve our memory. So there is a lot of research trying to improve our memory. One of the most robust finding, I would say, is on the testing effect. So I said testing effect. I assume that for some of you, the heart start to jump once I say testing. And I know that we all associate testing with sometimes negative consequences, but the testing effect is actually something that could lead to quite a lot of benefit for you. So I do not know if you're familiar with that, and if not, maybe it's something that you will see how it can improve your memory. So the idea of the testing effect being described by Francis Bacon now 400 years ago. And over there, he wrote in this citation, if you read a piece of text through 20 times, you will not learn it by heart so easily as if you read it 10 times while attempting to recite from time to time and consulting the text when your memory fails. So what Bacon basically said is that you should not read the text again and again and again and again in order to remember it better. This will not be an effective strategy. A better strategy is to read it, but then to test yourself on what is it in the text. Try to test yourself and see if you do not know something, then have a look in the text and improve your memory this way. The idea is that when we retrieve the information from our memory, when we test ourselves, we improve our memory. Now, very similar approach was described by William James, who's considered one of the fathers of psychology. He's actually worked quite a lot on theology. And over there, he also described how we are able to improve, again, our memory by examining ourselves rather than learning by heart. And when you look on data that's coming from the paradigms that compare those who tested themselves versus those who read again and again and again, there is a finding that you find again and again and again, which is that testing effect is better than just reading the text frequently. So here just one example, there are so many. It shows the final test performance in terms of proportion correct. There is the testing, there is question generation, which is very similar to the testing. You need then to come up with questions that basically deals with the material that you learn. And this is again when you just read again the text rather than test yourself on that. You could see that the effect of testing is better than responding, which indicates that testing effect is much more effective tool in order to improve our memory. Now think about the way that you study material in school. Do you read again and again and again? Or do you try to use testing in order to retrieve the information? Once we retrieve the information, and this is one of the explanations why testing effect is effective, when we retrieve the information, we actually strengthen the information in our brain, and we are able to retrieve it much better in a real testing condition. Okay, so let me move now from the testing effect to training. Just one thing that actually is quite important. In the testing effect, the results there were obtained after 1 week. Okay, so this is 1 week later after they did all the learning here. It is important to say that because usually after 5 minutes, if people are going to be tested, those who read again and again and again going to perform better than those who did the testing. But when we're thinking about long term, like after 1 week, how much people are going to remember, testing effect is more effective. So I assume that you're not going to be tested 5 minutes later. If in 5 minutes you're going to be tested on a material 5 minutes after you finish the study, then of course just reading again and again will be very effective. But if you for test, this is not. Okay, training. I just want to give you here a very quick taste from physical exercising. So there's a lot of studies that try to examine whether physical exercise is going to benefit not only from looking slim and being able to run faster, but also by improving cognitive abilities. There are a lot of studies that are correlational, meaning that they did not try to do any manipulation on the participant in terms of the physical exercise in order to see that physical exercise really led to benefit in cognition. So, for example, they not took two groups, assigned one group to do one type of activity and another group to do another type of activity, and then compared those conditions. But they just looked how variation in the amount of training that people get, in this case physical exercise, is associated with cognitive benefits. So in this case, you could see aerobic capacity, okay, and there was a test that assessed aerobic capacity that these researchers used, and there was the performance on maths and reading achievement. What you could see is that there is a positive association between aerobic capacity and achievement. So let's take the maths achievement, which shows a stronger relationship. What you could see is that the increase in aerobic capacity is associated with better math achievement. It is a nice finding, but I want you also to bear in mind that this is correlation, okay? And correlation, association in this case, right, doesn't tells us that this is really a causal effect. Okay, it doesn't mean that the aerobic capacity led to better match achievement. It might be that it's related to other factors or the other way around. So, for example, it can be also as well that math achievement leads to better aerobic capacity, although in this case it seems a bit dodgy to conclude that. But let's say that it might be that those who have better aerobic capacity maybe have better schools, okay, that allows them to have more sports and more areas to do the sport, and therefore maybe these schools are better funded and have better teachers, okay, that allow them to improve them in terms of their match achievement. Um, so it might be that the link between them is not, for example, aerobic capacity that leads to much achievement, but other factors. So, for example, the type of school, or that maybe the parents of those children um, invest in them much more to go to extracurricular activities and having also better aerobic capacity, and also give them private tutorials in order to improve their math. So this may be another reason. So there are some studies that suggest that there is a causal relationship, but there is still not a very strong evidence in the case of children. There is actually very good evidence in the case of elderly, but I'm not going to cover it here. Okay, so this is the type of findings from elderly, um, showing that in the case of elderly, this is a meta-analysis. In meta-analysis, we take many studies, so it's not based on one study, but a lot of studies that examine the effect of physical exercise on um, cognitive abilities, and we want to see if across all the studies there is a picture that shows in the same direction. And what these studies suggested is that, especially for very demanding cognitive tasks that involve what we call executive function, so this is things that relate more to memory and mental flexibility, cognitive flexibility. So what did you find there is that exercise led to a larger effect compared to control on these task. There are also on other types of cognitive abilities, but the most notable one is on executive function. Okay, let me now tell you something about drugs and nutrition. So one of the things that it is important to bear in mind is that when we use, in this case, when I say drugs, is of course I'm not talking about um, illegal drugs. I'm talking about drugs that are used a lot of time for patients in order to improve their cognitive abilities, and what happened when these drugs been taken by healthy individuals. Um, and nutrition, of course, is something that is less problematic in this case. And I'm going to give an example of caffeine. But one of the things that I would like to mention before, when we talk about drugs and nutrition, but also on a lot of other aspects that relate to cognitive enhancement, is that a lot of time we find that more doesn't necessarily indicate better. So if we give more of something, in this case, if we give greater dose of nutrition or drugs, doesn't mean necessarily that we're going to find better effects. Okay, it's not a linear effect in this case. And this is this is an example showing that if someone, let's say, has a certain neurochemical activities in their brain, okay, so they have a certain, let's say, activity or concentration, and in a certain value, there is where we find that it is the most optimal. So this is, as you could see here, this is what we call inverted U function. Okay. Over here, too little is not beneficial, too much is also not beneficial, but there is a balance. There is a certain point, a sweet point, that it's actually the best one, and this is what we want. Okay, so if there is someone that has, let's say, a neurochemical activity, that if we will increase that, we give them a certain dose of drugs, they're going to reach the optimum. They're going to perform better. Okay, you can see here, going to improve processing efficiency. But on the other hand, let's say that someone is already at their optimum. If we're going to give here someone that at this point the drugs, they're not going to benefit, right? It's going to increase, the neurochemical activity is going to increase because of the drugs, and this is going to lead to impaired processing efficiency, so impaired performance in this case. Okay, so saying that, this is one of the studies that it's coming from Barota et al. Was published in Nature Neuroscience, and in this case, it's quite of an interesting study because the scientists gave to their participants, they gave them caffeine after they saw some stimuli that they have to remember. Okay, so they got some stimuli they had to remember, then they gave them caffeine after. And what they want to examine is if you take caffeine after you study, it's going to improve your memory. And they also took some saliva from the participants in order to assess the amount of caffeine that they have. And the finding that they obtained, which is quite interesting, you could see here the performance on the task, okay, and the level of caffeine. So this is the change in the level of the caffeine. You could see that if the change was medium, there was then the best performance on the task. So small that it is very low or none, or too much is not optimal. Okay, we need to have again a sweet spot in order to lead, as you can see here, in order to lead to the best performance. Okay. Moving from that, I would like to take you to neurotechnology, and this is actually the type of research that my lab worked quite a lot on. And here I want to take you to a question that we try to examine quite a lot, and we try to make people better cognitively. We try to make them a lot of time experts in what they do, to perform very, very well, that we can say, oh, well, look, they perform like experts. And one of the questions is whether neurotechnology can facilitate that. Okay, so instead of people studying, for example, 20 days in order to become experts, they need to study much less. Let's say, for example, just for the example, 10 days. Okay, if we can really do that, that's going to be quite effective, and especially if we can also improve their memory later on. So those who receive in this case the treatment, going to remember the information much longer than those who just studied in the more conventional way. But the question is, how can we really know if someone is an expert? And for that, we have some very smart paradigms that allows us to assess expertise. One of the things we assume is that expertise, people, if they are experts, they process things automatically. Okay, and by meaning automatically, the idea is that we are able to do things without putting a lot of resources into that. So take, for example, a driver. Hopefully no one of you, if you have driving license, drive like that. And in this case, it should be an experienced driver, okay? They're able to drive automatically, if you think about it, right? They do not pay a lot of attention when they do that. They do not put a lot of mental resources when they are driving. They can do several things at the same time, and hopefully not causing to any accident. Of course, I'm not recommending that to anyone, even if you're expert in driving. But what will happen if someone will try to do that when they're still not expert? Okay, you could see the consequences of that, because they're not able to do things efficiently while doing other things at the same time. Now, of course, in the lab, we don't do this type of experiments. It's unethical. We have more basic tasks in order to assess expertise and automaticity. And one of the most known one is automaticity of reading. So I want actually to give you now the task. It's not exactly how we do it in the lab. In the lab, we record milliseconds, response time in milliseconds, and accuracy. But what I want you to do now is to look on the screen, and I'm going to show you words in the middle of the screen. And I want you to name the ink of the written word as fast as possible, okay? You just need to name the ink, okay? You should not read the word, just the ink of the written word, okay? And again, do it as fast as possible because we measure reaction times in the lab, but yours, of course, need to be accurate. So when you're ready, let's start, okay? So 1, 2, 3. Okay. What happens is that when you try to name the ink of the written word, you also read the word, right? Despite the fact that I ask you not to do that, this is because that you process the words without intention. Okay, I ask you not to do that, but still you do that because you're expert in reading. You read now for so many years that you do that even when you don't need to do that. Now, of course, if you're going to give that to a child that still doesn't master reading, they're going to do this task without a problem, right? Because they're not reading automatically. Now, let me give you another task. And in this case, this is a task that says automaticity of numbers. So how automatically you process numerical information. And here I'm going to show you 2 digits on the screen, one on the left side and one on the right side. And what I want you to do is to raise your hands in the side of the number with the larger physical size, okay? So if a number appears physically larger on the left side, you're going to lift your left hand. If it's on the right side, you're going to raise your right hand, okay? So just like that. And I want you again to do it really fast. So concentrate on the screen, and when it is on the left, left. So if it's on the right, right, and you need to do it really fast. Ready? Physical size, not numerical value. 1, 2, 3. Okay. So what did you probably experience is that when you try to raise your hand on the left side for the larger physical size, it might be sometimes confusing, right? If this number was numerically smaller. And this is because that you process number automatically, but also a very important aspect is that automaticity is correlated with our expertise. So the more expert you are, then process will become automatic. Now what happens is that I'm going to show you some data from um, from experiments, and over there we have trials in which this is what we call incongruent trials. So the larger numerical value here is physically smaller. Okay, so this is incongruency between physical and numerical size. And here this is congruent trial. Okay, the larger numerical value is also physically larger. And we can then calculate the automaticity by seeing how much people are confused in these trials. What you could see is that this is the level of 8 years old. This is the level of adults, okay? And this is what happens if you have adults. Both these groups, the adults and those who we call dyscalculics, are university students, okay? But the dyscalculics have problems with numbers. They could be excellent in topics that do not require numerical information. When it comes to numbers, they show the same level as those who are 8 years old. Now, what did we do in this case? We actually want to see what happens when we give to participants to train on numbers, so artificial numbers, so not the numbers that we're familiar with, but symbols that correspond to numerical values. And these people need to learn these symbols, okay? They learn a new, if you want to think, numerical system. What will happen to their automaticity? Can we then improve their automaticity? And this is what we found. Basically, what we did in this case, we put electrodes on the participant's scalp. So don't get so alarmed. It's not electrodes that give a strong electric current. It's electrodes that give a mild electric current. So this is something that it is not painful. It is painless. It's considered to be safe if you know how to use the equipment, of course. And it allows us to change how the brain works. So when we excite regions that are involved in numerical information, we could see that participants after, in this case, after 6 days of training on these symbols, showed automaticity. So they just showed a similar effect to what you could see here with adults. This is after 6 days, yes? This is after around 12 years or more. This is what happened when we give sham stimulation. So sham stimulation doesn't provide the same stimulation as here, but it gives the same sensation. So people cannot really tell if they receive real stimulation or not. This is in order to control for things like placebo effect. Okay, if people feel that they receive treatment, they might perform better, but this is not because the treatment really is really effective. This is just because that they feel that they are part of an experiment, and this is probably going to be effective. And this is when we try to inhibit this region. So you could see there was not real effect there, but it performed worse than when we excited. And it's quite interesting to see that these levels is very similar to what you find here with those with dyscalculia or children. But this study, of course, is on adults, on university students. And you could see that we can, with neurotechnology, improve the amount of automaticity in this case. So then we move to another type of stimulation, which I want to show you as well. This is a very interesting type of stimulation because it uses noise, it uses random noise. We give electric current at different frequencies. And the idea is that if we apply noise that you could see here, the shaded green, okay, to a stimuli, we can improve the signal of this stimuli. So you can see how we can amplify the signal from the stimuli. And this can improve information processing. So this is something that it is attributed to a phenomena that is called stochastic resonance. And we know about some benefit of noise in different domains. One of the ways that I want to show you is the perceptual domain. So you could see here a picture that we could not really see what is it if we're going to apply here perceptual noise. Okay, so noise at the perceptual level, just to apply noise to this stimulus, you could see that it improves the that it improves our ability to detect what this stimulus is. So what we did, we applied this type of stimulation to the brain of students who university students who try to we give them a task which was to study arithmetic. So what did we try to do here? We gave them to study arithmetics while stimulate regions that are involved in arithmetic learning. The arithmetic learning was around half an hour a day for 5 days. In one of the tasks, they had to apply an algorithm. Okay, so it's algorithmic learning, and the other is to remember the solution for an equation. So very similar, like if you know that 9 times 4 equals 36, you just remember that. That's what we asked them to do as well. Now, what you could see here is that those who receive the noise stimulation, TRNS, learn faster. So this is learning rate. They learn faster than those who receive sound. Okay, so they learn faster, they reach a level that it is associated with a very good learner. This is when they learn the algorithm, okay, the algorithmic learning, and the similar effect was when they learn by heart. Okay, so this is what we call drill learning. So here again, random noise stimulation led to better effect than sham. Okay, so just to remind you that sham is the placebo condition. Okay, so in this case, people do not receive real stimulation for a very brief period of time, and both people will report very similar sensation, both for sham and PRNS, and um, they could not reliably tell whether they received sham or PRNS. Now, after half a year, we ask the participant to come back to the lab, and we ask them to do the same task, the calculation, the algorithmic learning that they learned 6 months before, or give them new problems, but they had to apply the same algorithm. And what you could see here is that after half a year, those who receive random noise stimulation perform faster, okay, than those who receive sham, both for the old problems and for the new problems. You could see also that overall both random noise stimulation and sham remember better the old problem than and therefore they perform faster on them than the new problem, showing that even after half a year they could still perform better on the material that they trained before. It's important to say that in this case, after half a year, those who were in the random noise stimulation, in the stimulation group, did not receive any stimulation. Okay, so they just did the task without stimulation at all. To be just fair, in this study, I have to say that there was a much smaller sample size than the amount of the participants half a year before. So we need to really take this evidence with a grain of salt, although later findings showed that again, this type of stimulation, TRNS, can lead to long-lasting effects. Now, the effect is also, we find it only for calculation. If we looked what happened with the drill learning, when you just learn by heart, it seems that in this case, stimulation was not beneficial. Now, this looks very promising, and I want to mention some caveats or some things that we need to bear in mind before thinking, oh, wow, maybe we can use that in order to improve our abilities. First of all, it's still mainly, I would say, experimental tool. And this method as a whole is called transcranial electrical stimulation. So we stimulate our brain from outside, okay, by placing electrodes on the scalp. So it's called TES, transcranial electrical stimulation. And there are some companies that actually take these findings and try to sell these type of devices for consumers. So this is an example of a company that suggests that if you would use it, you can improve your some type of abilities. I'm not going to give them publicity, but I want to say that this is really we're still not at this stage. I would like to give you an example. So in this case, in this study, we try to improve logic and reasoning. Okay, and one of the tasks that is used in order to assess for logic and reasoning is this task. It's type of you have different shapes, and you need to find based on a certain rule what is the missing shape. Okay, so here, for example, we have a combination of both shape, color, um, and size. And you could see that eventually, if you look on all of those, you can then decide what is the missing, um, what is the missing, um, what is the missing item here from these options. Okay. And if you look carefully, you can stop the video if you want to try to find it first without me telling you the answer. But the answer for that is 3. Okay? The 3 is the one that is missing here because you could see that there are all this. There is the triangle, the T, in white, in gray. The black is missed here, and also they are all the small ones. So this is also the small rectangular in this case. Here, it's something much more difficult. Okay, so if you want to try to think what might be the missing one here, again, stop the video, try to find there is a certain rule here. Okay, and if you will apply this rule, you can then find out what is the missing one. And I will tell you that the missing one is 2. Okay, so 2 is basically the addition. You can see that all the last figures are the addition of the first plus the second. If you put this on that, you get that, and so forth. And therefore, this will be the right solution. So we give to people to solve these problems, and we want to see if we can improve their performance with brain stimulation. There were several experiments there. I'm just going to show you one result, which we also replicated in another study. What we find out is that if you give stimulation at a certain frequency to an area that we know that is associated with performance in this task, you find that there is an improvement. Okay, lower values indicate that they were faster to solve these problems. Okay, but you could see that the improvement depends on how good they were with the task. Okay, so if people were really slow at the beginning, they benefited from the stimulation. If people were quite good, you could see that the stimulation was ineffective, or if you want even to think about it, it might even damage their performance in some cases, meaning that stimulation might be beneficial for some, not for others. So I think if you're just going to buy something that's just going to give you a generic stimulation, you can never know if it's really the one that fits you the best. So to conclude, I just want to say a few words about what we really need in order to impact society, to give an effective cognitive enhancement tool. One of the biggest problems is sample size. Most of the studies are based on small sample size. And we now have better understanding that small sample size is something that could be quite problematic, prevent us from having really accurate and reliable findings. So we need to have well-powered studies with good sample size. The other issue is replication. It's very important not to take just one finding and then make from that something that might not eventually be replicable. So it's very important to assess that. The other issue is double-blind and proper control group. So we need to have really good studies that the finding could not be because the participants know that they are in a certain group and therefore perform a bit different, or if you are the experimenter, you know who's receiving what type of treatment, and you might bias the participant even unintentionally. Okay, so double blind are really proper experimentally in order to lead to much more reliable and trustworthy results. The other issue is optimization and personalization. We really need to give the best type of stimulation or cognitive enhancement if it's a case of drugs and so forth. And we also need to know what to give to whom. You remember the inverted U shape, for example, that I showed you, right? In the case of drugs, you remember just the finding that I showed you on brain stimulation, right? Neurotechnology in order to improve problem solving and reasoning. Um, Again, we need to know who are the people that are going to receive this type of treatment and how we can personalize it in order to give them the best dose in order to improve their performance. The other thing is to be aware of side effects. So, people do not have here major physical side effects, but might it be that by improving a certain ability, we can impair another? You remember the story that I told you before about Adam and Eve, right? If we're going to improve our cognition, might might it be on another cognitive abilities? Is there a punishment, okay, that we need, is a price that we need to pay for improving our abilities? It's something that we still do not have a lot of knowledge on that. There are some findings that suggest that it might be the case, and this is a really long discussion. We can have about it if you want in the Q&A. The other issue is about mechanistic understanding. It's very important to know how we improve um, the type of cognitive abilities that we try to do. What are the mechanisms that are involved in that? It could also allow us to be more confident in what we find, but also to improve it even further. The other point is ecological validity. So most of the studies are coming from a lab setting, very controlled lab setting, mostly university students. It's a very narrow slice of the population. If we want to provide effective tools for cognitive enhancement, we need to do that outside of the lab on real tasks in order to really see that it is effective, and also not on a very narrow sample like university students, but on a much wider sample. The last point is addressing ethical challenges, and this is, I think, it's I'm not an ethicist, so there are people that are discussing that, but I find it a very interesting issue. So we need to consider who are going, for example, to use that. Um, Only those maybe with below average abilities. Should we give it to people that have really strong cognitive abilities? What it will cost our society? Sorry. What it will cost to our society? Will it increase the gap, for example, in our society? If we, for example, would just make the stronger even stronger cognitively, or will it reduce the gap in the society? If we will be able, just like in the task that I showed you on the brain stimulation, that those who were not as good, we were able to improve them. Will it basically going to cause to those people to perform better and close the gap? Who's going to have access to that in terms, are they going to be very expensive, or everyone can actually have access to them? So we would like to avoid things like the rich get richer in this respect. So it was, I hope that you enjoy very much from the presentation about cognitive enhancement. I hope that it give you a bit some food of thought, and I'm looking forward to our Q&A to discuss about it further. So goodbye, everyone.